All right, in this video, we're going to take a look at the average rate of change of a function. And the average rate of change over a closed interval with endpoints a and b of a function is nothing more than the slope of a line that connects those two endpoints. So it's our change in our f of x values, or divided by our change in x values. So we have f of b minus f of a, which is the y-coordinate of the function at x equals b, minus the y-coordinate of the function when x equals a, divided by b minus a. This is our x2 minus x1. This is our y2 minus y1. So it's just the slope of a line. So here we have a function, and we've connected 2 points on them with a red line. This first one has an x value of a, and whatever the y coordinate is, that's f of a. This one over here, the second point, has an x value of b, maybe it's like 4 or something, and what the value of the function is at that point is your f of b, or your y coordinate. And so all you're going to do is you're going to calculate the slope of the line connecting these 2 points. I'll give you the value of a, you'll plug it into your function to get this y coordinate. I'll give you the value of b, you'll plug it into the function to get this y coordinate, and then just calculate the slope like we did in the first example for this section. All right, so example 4, find the average rate of change for each of the following. Here we have f of x equals 1 over x between 1 and 5. So the average rate of change of this function between 1 and 5. So first thing we want to do is we want to plug in 1 for x and 5 for x. When we plug in a 1 for x, we get 1 over 1, which is 1. When we plug in a 5 for x, we get 1/5. So what this question boils down to is what's the slope of the line connecting the points 1, 1 and 5, 1/5. So we have f of 5 is 1/5, f of 1 is 1, and now we want to find the slope of the line connecting these points. We have 1/5 minus 1 over 5 minus 1. I don't like complex fractions, so I multiply everything by this tiny denominator here, which is 5. So everything gets multiplied by 5. And when we do that, we get 1/5 times 5 is 1, minus 1 times 5 is 5. 5 times 5 is 25, minus 5 times 1 is 5. And this simplifies to negative 1/5. So average rate of change, just plot those or plug those 2 values of x in, you'll get your values of y, and then just find the slope of the line connecting those 2 points. So part B here, we have the function 3x squared plus 2x minus 7. We're going to, between x is negative 2 and x is positive 2. So if we plug in negative 2 into our function, we get 1. If we plug in a positive 2 for our function, we get 9. So what's the slope of the line connecting those 2 points? What's the slope of this segment? And our change in y value is 9 minus 1 over 2 minus negative 2. We get 8/4, which is 2. So the average rate of change between these 2 points is 2. Now, in closing, I do want to say that when you get into calculus, you'll be looking at what happens to the average rate of change of the function as these 2 values of x, in this case the negative 2 and 2, what happens as these 2 values get closer and closer and closer together. So your outputs will get closer together, and that's called the instantaneous rate of change, which you'll learn about in calculus. So it's based on what happens as these values of x get closer and closer together. So, all right, that about does it for this video. Thanks for watching, and I'll see you next time.